To implement text to speech with OpenAI, you can use the OpenAI API along with a text to speech service like Google Text to Speech or Amazon Polly. Here's a general outline of how you can achieve this.
Hi, this is Amnish. Welcome to my channel. And today I'll be talking about how I implemented text to speech in ChatCraft using OpenAI API. And I'm pretty confident by the end of this video, you'll be able to implement this feature for your projects as well. All right, so before going into further details, I want to make sure everyone knows what ChatCraft really is. ChatCraft is a fully open source AI chatbot that is primarily developer oriented. Now, you might ask, what do you mean by that? Apart from what ChatGPT or many other popular AI chatbots have to offer these days, ChatCraft extends on those features by providing various functionalities that might help developers boost their productivity in many cases. I'll quickly go over some of those functionalities. So I can define custom ChatCraft functions and use them in my regular chat.
Hello World.
We have various inbuilt commands, and you might want to run code natively in the browser that's given to you by the LLM response. That's also possible with ChatCraft using WebAssembly. That's the output. Now, this might not be fully developer oriented, but you can generate images as well without leaving ChatCraft. So it's going to take its time while it's processing, and we get a beautiful Shire image with the help of AI. Now that everyone might have a brief idea of what ChatCraft is really about, I'll switch back to talking about how I implemented text to speech for this application. All right, so the first thing that I want to point you guys to is OpenAI's official text to speech documentation. It's pretty clear and easy to understand. They provide you with a quick start snippet, and I believe they support both Python and Node. Since we are dealing with web dev right now, so I'll choose Node. And they have a couple of audio quality models that I'll also go over in the demo. We have and this is, I guess, the best part I found. They have various voice options, and all of them are really good. I'll actually show you a brief
The sun rises in the east and sets in the west. This simple fact has been observed by humans for thousands of years.
crazy, isn't it? It's way better than any previous text to speech tools I've used before. And there are some more options, but we're not concerned about those. But again, and it's always a good idea to start with the official documentation. I also started with this snippet and was able to turn it into a function that I'm currently using in my application for all text to speech operations. The first thing that I do is I create an OpenAI instance. In this function, I have to give it the API key, the API URL, and all the other metadata. And after the instance is created, I'm sending a request to the OpenAI text to speech API to give me an audio. Then I am transforming that audio blob into an audio URL, and that can be used later on with various use cases in the application. All right, so to reiterate, all I have to do is pass the text content that needs to be processed, the voice that needs to be used for audio generation, and lastly, the audio quality model. And I'll receive a promise that will resolve to the audio URL that I can later use for audio playback. All right, so now that we have this function, it's actually time to implement some features. The first place where I actually used this was while the LLM response is being generated, the audio announcement should also work. And I've provided a feature where people can either enable or disable automatic text to speech announcements. So let's say I ask a question, and it's a very vague question, but just for testing purposes. Let's say,
Python is a high level, interpreted programming
all right,
language known for its simplicity and readability. Here are some key points about.
all right. So you'll notice that as the response was being generated, it didn't wait for the entire text to be available before started announcing. That's because I am breaking the entire response into sentences, storing it in a buffer, and then sending those chunks for text to speech generation. That's a little complicated process, but I'll actually try to walk you guys through it. So this is where I'm getting data from the LLM, and current text is basically the current state of the response that we have right now. What I'm doing is I'm storing whatever I have right now in a buffer variable, and I'm keeping track of a cursor, uh, which tells me how much I have already processed for text to speech generation. And as I keep receiving more and more LLM response, what I do is I try to break the buffer into sentences, and if possible, if the sentence is too long, I try to break it further into clauses using a natural language processing library. It's called Compromise. I'll put a link in the description, but this is an open source library. That's what I'm using for that. So what I do is I try to parse the sentence, break it into chunks, and finally what I do is I send those chunks to the OpenAI text to speech API for audio generation. And as I am receiving, so this is the text to speech function that we just talked about. What I'm doing is I send it the text to be processed after parsing. And then I receive an audio clip URI. This is actually a promise, and what I do is I've implemented an audio player hook that allows me to maintain a queue of audio URLs. Why that? That's because I want to make sure that all the audios are playing in order, because these are all asynchronous requests, and I don't have control over which one gets processed first. So really, in order to make sure that these are playing in order, I have to maintain an audio queue. So I can actually show you. So this is the use audio player hook that I've implemented. What I'm basically doing here is I'm maintaining a queue of audio URLs. These are basically promises. Not storing the URLs directly. Um, this uh, so this is a little complicated, but I've explained everything in my blog post over here. I'll attach a link in the description, but I've basically explained everything from buffering, and I even have a whiteboard um, of my pseudocode of my algorithm. So if you want to go into more details, you can look here. The entire code is there, and all of my explanations are also there. But yeah, that's that. What I'm basically doing is maintaining a queue of audio URLs, and then playing them in order. Furthermore, I have wrapped this entire audio queue in a context, in a React context, and I'm providing that context at the root of the application over here. So in main.tsx, that's where I am. So audio player provider, that's where I'm providing it at the root of the application. Now, the reason I'm doing this is so my audio queue is globally shared throughout the application, and with that, I can make modifications to that queue. I can operate on that queue from anywhere inside the application. So let's say I wanna stop playing the audio. I wanna clear the audio queue just by the click of some button. So let's say while the response is being generated, if I click on this button and disable text to speech, that announcement, any audio clip URLs that have already been generated, or those promises, all of the that audio queue is going to be cleared if I use this function now, because this audio queue is global throughout the application. So that's the idea. That's why I am doing this. Anyways, I've written about this entire hook in detail in one of my other blog posts. I'll link that in the description as well. But that's the basic idea of how it's working. You just write a text to speech function that's going to make API calls to OpenAI's text to speech API, and it's pretty much up to you how you want to use the generated audio clips that it's going to return you. In my case, I am using it for various purposes. One of them I just demonstrated to you in code, and now I'll quickly show you guys what kind of features I was able to implement using this service. So the first thing is, of course, real-time audio generation as I ask a question. So let's say,
Sure. Here's an interesting fact. The
That's the
name Python for the programming language was inspired by
and
the
I can
British.
even tell it to shut up just like that. The second thing, you can click on any message, and in the options, just click on speak. So it's going to re-announce that.
Sure, here's an interesting fact. The name Python for the
I can
programming
even
language was
cancel it
inspired by the
by
British
clicking
comedy
on
group
speak for some
Monty
other
Python.
message. So it's going to stop playing that
Tell
and
me
start playing
something.
this. That's the other one.
Tell me something, G, about Python.
Yeah, so that works. That's the second feature I was able to implement. Another thing is you can even download it as audio, and when you're downloading it as audio, I am actually using the TTS 1 HD model. Remember we talked about the audio quality models at the beginning, so that's where it comes into play. When I have to generate the audio in real time on the fly, I care about latency and performance. So I'm using TTS 1 standard model to reduce that, even though quality is almost the same, but I still need better performance. And when you download it, we don't really care about how long it takes that much. So here I'm using the TTS 1 HD model. That's the difference. So I can click on download, and it's going to show you a toast message, and it's going to download it for you. I can click on
Tell
play,
me something.
and that works as expected. All right, so the last feature I want to talk about is the ability for users to select what kind of voice they want to use. So I'm allowing the users to select that in user settings. You can choose any kind of voice, and I've also provided this button for quick audio previews. If you, in case you want to know what this voice sounds like, you can select the voice and click on this audio preview, and it's going to introduce itself.
Hi there, this is Fable. Hi there, this is Alloy.
Hi there, this is Onyx.
That's my man Onyx right there. All right. So I guess that's all about the features I wanted to show. It's still not in production, but hopefully it's going to get merged soon. When I say not in production, it's just the ability to select different voices and some other functionalities. The pull request is still up here. I'll put a link for this in the description as well, in case you wanna go into the nitty grits and review my changes. But yeah, that's pretty much all I wanted to demonstrate in this video. Thank you so much for watching and hope you enjoyed it.